Today's video is going to show you how we're going to use trig integration with U-substitution. And one thing we want to remember when we're doing integrals with trig and U-substitution, there's two things we want to let U equal. We're going to let U equal, and get my pen out here, we're going to let U equal two things. We can let U equal the angle, or U is going to be an entire trig function. Okay, so if we look at our first example here, we have the integral of 8 sine of 8x. What we're going to do here is we're going to let U equal the angle. So we're going to let U equal the 8x right here. The derivative of U is 8 dx. We write it in differential form, so derivative of 8x is 8 dx. And we actually see that we have that in our problem here. We have 8 dx right here, and that is equal to du. So there's no adjustment needed, and our new integral in terms of U winds up just being simply the sine of U du. And if we know our integration rules, and we know that the integral of sine is negative cosine U plus c, then all we have to do right now is plug in U back in, so we have negative cosine of 8x plus c. So that's a pretty simple one to start off with. Let's take a look at another one over here. Here we have the integral of x times the secant of x squared, tangent of x squared. So I'm going to start off again by letting U equal the angle. So I'll let U equal x squared. The derivative of that is going to be 2x dx. And you can see that I have U right here and U right here, but I only have x dx left over. So I do have to make a little minor adjustment, dividing by 2. So I got 1/2 du is x dx, and that's what I wanted. I wanted x dx. So my new integral, I'll have the 1/2 that comes out front, and then I'll wind up with the secant of U and the tangent of U du. And again, knowing your integration rules, the integral of secant tangent is just secant. So I'm going to have my answer as 1/2 secant U plus c. Putting my U back in, I wind up with my final answer of 1/2 the secant of x squared plus c. So there's my final answer for the integral there. So this one, again, we were letting U equal the angle. We had a little minor adjustments of dividing by 1/2. And so let's see if we can get one that gets a little bit more complex here. Here I have the cosine to the 4th of x times the sine of x. Now, when you look here, you see that the angle is just basically x. So in this problem, I'm going to actually see if I can rewrite so I can see something here. I'm going to write this as cosine of x quantity to the 4th times the sine of x dx. This will help us see that letting U equal something that's inside. So I know that I'm going to let U equal the entire trig function. So I'm going to let U equal the cosine of x. And the derivative of cosine is negative sine x dx. Now I have sine x dx right here, but I have a negative, so my little adjustment is going to be a negative du equaling sine x dx. So now my new integral, with this being the U and this being a negative du, the negative comes out front, so I'll have a negative integral of U to the 4th du. And again, the reason why we do U substitution, we go from really complex to really simple. Integrating U to the 4th winds up being U to the 5th over 5, raising the power by 1, dividing by the new power. So my final answer, I'll have a negative 1/5, and then I'll have cosine to the 5th of x plus c. So this example shows how we had to make U the entire trig function for the cosine of x. Let's look at our last example here. Here we have the cosine of x divided by sine cubed of x. And again, once again, I'm going to help myself so I can see it here. I'm going to write this as the cosine of x divided by the quantity here of sine of x, quantity cubed, dx. So again, letting my u be what's inside. You can see that the angles are very simple. It's just 1x there, so nothing really happening in the angles. So therefore, I want to try letting u equal the trig function. So we let u always equal what's inside, so the inside function here winds up being sine. And then the derivative of sine is the cosine of x dx. And you can see that in our problem, I have cosine of x dx. That is my du, which means I'm going to wind up with u cubed on the bottom. So my new integral in terms of the variable u simply winds up being 1 over u cubed du. And in order to integrate that, we know that we have to bring that up top, u to the negative 3 du. So if I raise the power by 1 and divide by new power, I've got u to the negative 2 divided by negative 2 plus c. So I know that I'll have a negative 1/2 out front, and on the bottom, the u to the negative 2 goes down to the bottom because of the negative exponent. So that tells me I'll have sine squared x. So I can rewrite this neatly now as negative 1 over 2 sine squared x plus c. So there were 4 quick examples of using U substitution with our trig integrals.